Okay, so the presentation that I'm giving today is actually going to be somewhat similar to one that I gave in Chicago a few months ago, but the goal here will actually be to sort of look into some things in quite a bit more detail. So the core sort of idea that I presented back then is basically that if we try to look at the benefits of some of the technologies that we're developing, things like Bitcoin, things like generalized contract platforms, some of these other ideas like DAOs, and if we try to see what actual value that they could conceivably actually provide to society in place of centralized systems that exist today. And the conclusion that I came up with is basically this concept that I called generalization back then. You could call it, you could call it abstraction, I suppose, which is basically that instead of having some service be monopolized by a relatively small number of providers, you look to as many industries as you can, and you try to look at every single player in that industry. So not just service providers, not just consumers, but even every conceivable kind of intermediary. And you try to see if each one of those roles could somehow be turned into basically some kind of a system where anyone can participate. Like, you can call it a market, you can call it a community, you can call it whatever you want. But the general idea being that it's being open system, open participation, and the key point is that cryptography is used to ensure security. So just to start off, I'll talk about what we already know. So this is the way that I explain blockchain technology. So this is an explanation that it applies to. It does. Now notice here, I don't talk about coins. I don't talk about UTXOs. I don't even talk about blocks over here. And this is something that could apply to Bitcoin, could apply to Namecoin, could apply to Ethereum, could apply to a cryptographic land registry. But the idea is that what a blockchain is, and it's also an explanation that I actually used at a banking conference about 3 weeks ago, and people understood it, which is that a blockchain is three things. First of all, a blockchain has a state. So a state basically is it's a shared database. It's a set of data it's a set of information that everyone in the network agrees upon. The second part is the meaning. So what does the database mean? So by itself, a database is just numbers, and numbers theoretically could mean anything. If I have an account book with the number 93, it could mean that I have 93 bitcoins, or it could mean that I have 147 bitcoins because we're using base 12. So actually, I think that's 135 bitcoins. So so we have the meaning. Then the third thing is you need a state transition function. So a state transition function, basically, it takes a state and it takes a transaction, and it's the function that lets you determine, first of all, given this state, is the transaction valid? If not, it's invalid. But if it's valid, then it gives you what the new state is going to be after that. So given this sort of abstract explanation, let's actually look through a few examples. So first of all, you have Bitcoin. So Bitcoin, the state is just, now you can think of it as transaction outputs and who has and which script corresponds to which transaction outputs. The simpler version is you have a list of accounts have addresses, and you have balances. The meaning is that the balance here represents currency units. It represents how many of these so-called Bitcoins you have. And the state transition function is, well, if you have a transaction, that transaction has a sender, it has a recipient. If the sender has enough money, then so if there is an entry in this little database of at least the transaction value, then you subtract the transaction value from the sender's entry and you add it to the receiver's entry. So basically, formally speaking, this basically is the definition of a currency or a financial system. Namecoin is decentralized DNS. So here what you have is your database basically stores domains and domains and owners. So in Namecoin's case, you can register domains inside of Bitcoin. You can instead of something like bitcoin.com, you could register bitcoin.bit. You could register Inside Bitcoins Tel Aviv.bit. And the idea is that your computer is that if you have the special Namecoin plugin, instead of checking some centralized DNS server, what IP address you use to access inside Bitcoins Tel Aviv.bit, you would check the network. You would basically check either your local Namecoin client or some other client. What is the entry corresponding to that domain? So that's the meaning. That's what the Solr database means. And the state transition function is, well, if there's a domain that hasn't been taken yet, you can take it. It's a bit more complicated because in practice there's also a currency involved here, and you can also transfer domains to someone else, but that's like the basic idea. So Ethereum, basically the idea is to take that same sort of concept and try to generalize it. So here what you have is so in Ethereum the state it contains these objects that are called contracts. So contracts have three things. Contracts have their own little internal databases, and they have code. And what we're trying to turn Ethereum into is basically a platform for decentralized applications. So the way that I sort of take all these three different components and fit them into this model is that, so first of all, you have the state. So each contract is an object on the blockchain. It can have its own database. That's the state. Now, for the state transition function, that's what the code is for. That's why we have the Ethereum virtual machine. And then what does this contract with code mean? Well, your job is to actually write a DApp, a decentralized application, which is basically kind of like a graphical interface. And the point is to explain what the numbers actually mean. So, and explain what people are doing when they're pressing this button. Are they just pressing a button to move some numbers around, or are they sending their entire life savings to Bitcoin Savings and Trust, or are they doing something else? So basically, contracts, you can think of them as being like a generalized interface for consensus computing. So you could write your own currency inside of it. You could write a name registry inside of it. You could write a land registry inside of it. It's basically a tool that you can use to make any kind of computing with these three conditions. So computing on the Ethereum blockchain is fully transparent, it's auditable, and it's guaranteed to execute. So you know exactly what's going to happen. The object is guaranteed to stay there if you send a transaction. It's guaranteed to have a certain effect, and everyone sees what the effect is. But the price you pay is this something like a 10,000x penalty. It's way slower to execute, and it's 10,000 times more expensive because you're doing things on a blockchain, and all the computations get verified by something like 10,000 nodes. So that's so to move on from here. Basically, the general pattern that I'm going to make to talk about how do we take this principle of generalization, so this principle of sort of creating a layer for something such that anyone can participate, and applying it to lots of other things as well. So what we're trying to do here, what we're trying to do with Ethereum basically is we're trying to lower the barrier to entry in terms of creating your own decentralized protocol. So Bitcoin, they had to create their own blockchain. They had to get mining hash power, pay for mining hash power. In the case of Namecoin, they had to also create their own blockchain, build a client, do all sorts of things. And what we've created is we've basically created a general interface that anyone can use in order to create their own decentralized application and that could be as small as it needs to be. It works, and it's fully secure even if it has like 4 users. So the general pattern here is you can think of it as 3 phases. Before 1.0, people didn't know about this whole decentralization thing. The idea is we need centralized intermediaries. Well, if you have a financial system, somebody's got to run the database. You need some kind of intermediary to manage things like consumer protection. You need some kind of intermediary to store all the data for the domain name registry. 1.0, so this is just Bitcoin by itself. Well, no, we don't. We have decentralized databases now. Yay! No more intermediaries ever. So that's it's progress, but it has some problems. So sometimes we do need intermediaries. But the promise of 2.0, this promise of abstraction, is that basically it's to replace centralized intermediaries with a market mechanism, that allows new intermediaries that provide better features to sort of plug themselves directly in. And it's a system where people can choose as much intermediation as they want. So just as a case study of what I'm talking about here, let's look at Skype. So the history of Skype is that originally it was actually a fully peer-to-peer system. It's even one of the success stories of decentralization in some sense. It's a system where all the messages are passed through a bunch of nodes, and there weren't any servers that were run by Skype, and the whole thing sort of just worked. So when Microsoft bought Skype, they added in this concept of supernodes. Basically, they added these special nodes to the network, and at this point, I believe supernodes are basically mandatory. Like the Skype network would not run if the supernodes were to disappear. So what is the good side of supernodes? Basically, more efficiency. You have nodes that are guaranteed to be very well connected to everything else. Messages can pass through really quickly. You only need 2 hops to get from any node to any other node instead of maybe 4 or 8 or 16. Bad news: more centralized control. Skype is still, at the end of the day, a centralized system. There's no incentive not to make the whole thing quietly hackable by the NSA. There's no incentive, and you have every incentive to try and add proprietary features. So, but on the other hand, there's also these, they add these supernodes for a reason, to make the network work better. And how do we make Skype more decentralized and keep the benefits? So the optimal solution is, in theory, something similar to what MadeSafe is working on, which is basically use something like proof of bandwidth. And the principle is you have a decentralized network, but you allow people to build supernodes. You allow anyone to build a supernode. And the theory is that the network would somehow auto-detect these supernodes as they appear, and route more traffic through them and rely on them to do certain functions. And there would be some kind of protocol which would appropriately reward peers based on the level of quality of service that they provide. So another case study, mesh networking. So originally, we've had the centralized internet for decades now, but it has problems. ISPs don't innovate. You have net neutrality problems. You have problems that, quite frankly, in the telecom space in general, it's kind of silly that you have to pay for $1 for a megabyte if you're doing something called roaming, and plenty of monopoly problems. And now, in order to resolve a lot of these issues, people have been trying to solve this problem for 10 years, how to do mesh networking. So the idea is that instead of a centralized internet system, you would have basically anyone's computer could be involved in passing messages along from the client to the server. And the theory is that whatever message you wanted to send, it would sort of pass through every other computer in the system, and that's the way the whole thing would work. No more ISPs required at all. Yay. Problems. Between cities, so if you want to send a message from one end of Tel Aviv to another, that's fine. With modern technology, you could probably do the whole thing with like 15 or 20 hops. Let's say you wanted to send a message from, say, Toronto in Canada to Melbourne in Australia. First of all, that's over 10,000 kilometers. If each hop had a range of even, let's say, 1 kilometer, that's 10,000 hops. If each hop had a latency of 50 milliseconds, that means you'd have to wait 500 seconds times 2 for your message to confirm. So that seems to be. I mean, you can run Bitcoin on it, but you certainly can't run any kind of normal web application on it. But the other issue is, where are these laptops and cell phones in the middle of the Pacific Ocean? Because there is this sort of ocean between Toronto and Melbourne and all that. So how do we fix that? Incentivize mesh networking. Basically, the idea is that you have this protocol where anyone can be a node, and messages still get routed through the most efficient path. But the idea is that it's incentivized. So your node can charge for passing messages through it. And the idea here is that anyone can have nodes, and first of all, normal people with their laptops and cell phones can have nodes, and that's fine. But on the other hand, you could have professional companies involved as well. So I could start a company with the sole purpose of maintaining an undersea cable between Melbourne and Australia, just one wire. And there could be competing companies, like there could be a company running a wire from Australia to San Francisco, and there could be a couple of inner-city companies going from like San Francisco to Denver to Toronto or whatever. And between all of the professional and not so professional providers, graph search algorithms would be used to figure out what the most efficient path is, and that's how all your packets would be sent across. So this is basically the way that we could get both benefits at the same time. Consumer protection's another important one. So before Bitcoin, we had PayPal. PayPal mediates transactions, and if you as a consumer are unhappy, you can do a chargeback, and if the merchant's unhappy with your chargeback, they can start a dispute resolution process. Problems, 2.9% fee, monopoly pricing. Some applications don't need mediation, so if I'm buying something from Cheap Air, Cheap Air is a very reliable company, and if they do something bad, they're gonna become a lot less trustworthy, so I have a pretty good reason to trust them. There's no real need for PayPal to provide any protection for that transaction. And also PayPal has too much power, so PayPal ended up blocking WikiLeaks. They are basically being used as a sort of arm of the political apparatus in some sense. File sharing crackdown. There's also this unfortunate incident in Regretzy where PayPal's overzealousness ended up targeting a company that was, I believe, providing gifts for children. So this is the new approach. Bitcoin, we don't need consumer protection, with the obvious consequences. So what is the 2.0 solution? So Bitrated is just one of the services that we saw yesterday that's trying to do this. But the idea is that you use multisig, and you create a system based on smart contracts where basically anyone can be an arbitrator. And because it's all based on multisig transactions, it's first of all, it's a very efficient system. Anyone can easily plug in, become an arbitrator. But also, arbitrators do need to have control over the funds. It's a 2 of 3 system. So arbitrators actually need to cooperate with the sender or the buyer. And they will only be able to, basically they will only have one bit of decision. They would say, well, is the sender right or is the receiver right? So it's a much lower degree of trust. It allows pretty much anyone to participate in this sort of arbitration market. And if I'm buying from Cheap Air, I could just send to them directly no arbitration needed. If you're buying from some shady guy I don't necessarily trust, I might have lots of arbitration. If I'm buying a Bitcoin service, then I might decide that the people at PayPal just don't have experience dealing with Bitcoin things, and I'll get some Bitcoin-specific arbitrator. And so it allows for arbitrators to be specialized into very specific industries. It kind of helps solve the whole sort of, the judges don't understand technology problem, and it allows for reputation. So next case, governance. So this includes decentralized governance. People are trying to do things like decentralized organizations, DAOs, DACs. So one of the questions that I've kind of been wondering for the past half a year or so is, aside from being unregulated and all that, what benefits do all these DA stars have? So I did come up with an answer. So the answer is that basically, if you look at organizations in general, there's a sort of trade-off between how inclusive the organization is and the need for trust. So, for example, if you imagine a company like a bank, that bank's going to end up handling a lot of secret information, and if you create some kind of decentralized bank where anyone can instantly sign up and become an employee, then well, your secret information is going to end up getting leaks all over the place. So it's there's benefits to having a lot of the things be within a very specific set of users, and so. But the idea is that the reason why decentralized governance is effective is that you have this concept of through cryptographic proofs, in some cases, we will be able to basically make a lot of highly inclusive organizational models more trustworthy. So we'll be able to use cryptographic proofs to audit people's activities, to make sure that people are acting honestly, and by doing so, we will allow organizations to be more inclusive without making as many sacrifices. So there's a little sort of Pareto frontier chart to explain the idea. So the more inclusive you are, the less trust you have, but with cryptographic technology, we can sort of advance the frontier to some extent. So for DAO specifically, there's also this phenomenon that, in reality, in any kind of project, there's this power law distribution in terms of how much people want to contribute. So inside of any project, whether it's one of the crypto projects that you're making, whether it's something like Wikipedia, whether it's a company, there's people that wants to be involved in the whole thing full time, and they want to get paid full time. They want to sink their heart and soul into it. Then there's people who might be willing to, put in like 15 minutes of effort a week, and there's everyone in between. So centralized organizations, they just hire people, so they only get the left side of the curve. Now, the solution that Silicon Valley's come up with in the past 10 years is this idea of crowdsourcing. So you just grab whoever's willing to be a volunteer, and you let people sort of contribute what they want. So that also gets you the bottom. That gets you the people that are willing to just put in a bit of time. Now, and the sort of theory is that these sort of ideas around DAOs potentially let us grab just about everything. So who wants to be involved for 40 hours a week can be involved for 40 hours a week. If you want to be involved for 13 hours a week, you can be for 13 hours. If you want to be involved for like 1.7 hours one particular month and that's it, you can get that as well. And the theory is that if these sort of DAOs are correctly constructed, all of those levels of involvement would be appropriately rewarded, and the whole system would still be basically secure. It would not be vulnerable to exploitation. So, with governance, the question is, how do you do it? So so one application for decentralized governance is actually decentralized protocols. So things like decentralized currencies. You could apply this to something like, potentially we could have done this had, Ethereum already existed. Some of these like ride-sharing protocols, decentralized mesh networking. So the way it works is create a token, issue n units per period, and there is some process which determines the token recipients. So notice that the token issuance starts from 0. It just goes by n units a period, and the activity that gets rewarded is the activity, and should be the activity of actually contributing to development. So the benefits here are, first of all, it solves the public goods problem of development. So that's what Bitcoin's facing, that we have this multi-billion-dollar protocol with just 3 core developers. No pre-mining, no sale, there's no concept of privileged founders. The whole thing is kind of like, you could think of it as, even though there are going to end up being people who are more involved than others, power laws are inevitable. You're not going to have a class system, you're not going to have a concept of privilege. So one mechanism for doing this is this idea of delegate of democracy. So the general sort of way to describe it mathematically is that accounts can vote for themselves or accounts can vote for another account. Votes are transitive. So if I vote for you and you vote for someone else, then I'm actually voting for that third person by proxy. And if a cycle is detected, you can stop at some point in the cycle. And the accounts that ultimately get the most people voted for them, weighted by a stake, get the funds. So how is this? So this in itself is a mechanism of generalization, because we have 2 types of democracy. We have representative democracy, where you vote for representatives, representatives do everything, and we have direct democracy, where people vote on decisions. Representative democracy, it's more efficient because it's more professional and specialized, and whereas it has this problem that it does create this concept of elites, whereas general direct democracy, it's nice, everyone gets their voice in everything, but people don't really want to vote on most things. So with this sort of delegative method, you create you create the same sort of generalization mechanism, and people can vote for representatives on the things that they don't care about particularly, and they can make certain, if they care about a particular issue by a very large amount, they can vote on that, they can turn off their delegation, vote on that issue directly. Another mechanism is this idea of feudarchy. So this is something proposed by Robin Hanson in 2000, originally in the context of political systems, but my opinion is that actually if this gets anywhere at all, if it succeeds anywhere at all, then decentralized protocols is where it will succeed. So the idea is we issue you let anyone come up with a proposal, then for each proposal you create a sort of separate token, and you create a market for that token. It's basically a prediction market. So, and the idea is you create some kind of market system where all these different tokens float. And the theory is that, first of all, whichever one of those, all of those markets correspond to a particular proposal for how the funds should be spent. Eventually one proposal is going to win. On the proposal that wins, all the tokens in the market get converted into real tokens, and on all the other markets, all the trades just get reverted. So the idea is on each individual market, the idea is that people basically buy and sell, and they try to figure out what exactly is the value of the coin going to be if this particular solution gets proposed. And then the solution that leads to the highest expected value according to the market is the one that gets chosen. So another approach. Maybe there's very interesting ways to combine these two. You could do something, there's something called predictocracy, which is where you have a feudarchy on people's approval of the action in the future. So reputation's another thing you can generalize. So right now we have a couple of these centralized mechanisms: credit scores, certification bodies, government licensing bodies, criminal background checks. But the idea is that in reality, in the world, we have the exact same power law distribution in terms of how much information we have about different things in the world. For each one of us, there is going to be a few people that know a lot about our lives, about what we're doing, whether or not we're trustworthy. There's going to be more people with less information and much more people with fewer information. And the idea is to try to create some kind of decentralized reputation system where anyone can participate. So these sort of specialized bodies can participate, us as individuals can participate, and everything in between. And both welcome. And so there's a couple of protocols that try to do decentralized reputation to some extent. Eigenvector trust metrics are one of them. So the general idea that they all try to go for is that if I trust you and you trust some other person C, then that means that I can also trust C to some extent. And so there's trust Davis is interesting because it's also got sort of baked in incentives, so it's got a built-in insurance mechanism. So what else can we generalize? Goods of physical delivery. So you have people who are professionals who constantly deliver things from one city to another, but you also have people who are just normally on their lives driving downtown, and in theory they would be willing to take a couple of items on the same route that they're already taking at very low cost. Information gathering. There's a project called TruthCoin. Also, consensus algorithms themselves. So this is actually one of the ideas in scalability, which is that there's a sort of Pareto frontier between how much a transaction costs and the level of security that transaction gets. And if you let people sort of choose exactly the level of consensus, ideally even the kind of consensus that they want, that might be an interesting approach to making blockchain scalable. So basically, the idea is that the main benefit one of the largest benefits that I'm seeing in this industry is precisely all of these different ideas, the idea of creating these different mechanisms for specific industries to try to make them maximally inclusive, to create a system where anyone can participate, all these sort of nice things like permissionless innovation, permissionless participation, and so forth. But at the same time, use mechanisms like cryptography, use mechanisms like reputation, all these different proof of X's that are coming out to make it secure at the same time. So. Time for one or two questions.
Hi.
Yes.
I'm not sure.
So that's one of the parameters that you can choose. Like you could make it a day, you could make it 2 weeks, you could make it a year. I think it might depend on how important the decision is. So if a decision is more important, you might even want to let the market take longer because that might make the whole thing harder to exploit. So some of the scalability ideas might end up being in a future version of Ethereum. Most of these, I would say, are more applicable to applications which may or may not want to use Ethereum for some part of their functionality.
So specifically, I'm referring to how are you compensating contributors to Ethereum?
Right. So right now, we kind of did go for a centralized model. The reason is that the decentralized protocols to support the decentralized model didn't really exist yet. But I think it's one of these sort of decentralized governance models deserves to be tried out. And if one of them turns out to work really well, then I'd be happy using it to develop Ethereum going forward from some point. Yep, I've talked to them. Okay.